In this example, we are going to verify a trig identity. And so we have the left side, we have the right side. We're going to mess with the left side to see if we can get it to equal the right side. Now, on the right side, I noticed that I have a double angle identity. And so I need to keep in the back of my head that I'm looking for a 2 sine theta cosine theta on this side. As soon as I have that, I can substitute it out with sine 2 theta. All right, so I'm going to distribute everything together and let's see what we can get. So we're going to multiply 4 sine theta minus 4 cosine theta times 4 sine theta minus 4 cosine theta. All right, so let's distribute. So we have a 16 sine squared theta, and then minus 16 sine cosine. And then if we go here, then we have another minus 16. And I'm going to put the order sine theta cosine theta, just to make it have a better feel for like them being like terms. And then plus 16 cosine squared theta. All right, so I'm going to clump these two next to each other because of the sine squared cosine squared. There's something I can do with that. And then these are like terms, so I'll put them together. So this is going to be a 16 sine squared plus cosine 16 cosine squared. And then if I put my sine cosines together, that's going to get us a negative 32 sine theta cosine theta. All right. So here I have a sine squared plus cosine squared if I factor off a 16. And that one's good because sine squared plus cosine squared is 1. So that will become 1. And then that'll get us our 16 that we're looking for. Now over here, this is the sine cosine that we were looking for up here. But it's not just a 2. So what I can do is I can rewrite this by taking it and factoring it into a 16 times 2 sine theta cosine. So if I factor a 2 off of the 32, and kind of separate out the sine cosine, those two are still my 32, but there's my substitution, right? This is a substitution of 1. This is a substitution of 2 sine 2 theta. And that is going to be then just a 16, because it's 16 times 1, minus the 16 times sine 2 theta. And that is exactly what we were looking for. All right, so that was verifying a trig identity, and that one happened to involve a double angle identity.